So let me read the problem for you. A and B are 2 by 2 matrices with integer entries such that A plus XB equal to 0 for X equal to 1, 2, 3, 4 are invertible matrices whose inverse have also integer entries. So you have to show that A plus 5B is also invertible and its inverse has also integer entries. Summer A plus 5B is minus A. How? That is not the case. Check it properly. A and B, they have integer entries 2 by 2 matrices. A plus XB. So for X equal to 1, 2, 3, 4. In fact, 0 is also there. You write it 0 also. Okay. For X equal to 0, 1, 2, 3, 4. 0 is also there in mistake. Are invertible matrices. So X equal to 0 means A is an invertible matrix. Then X equal to 1, A plus B is invertible, 2B, 3B, and 4. Okay. Is it clear? This is equal to 0.
Sir, how is A is 0 and invertible both?
A is not 0.
Equal
Why?
to 0.
Okay. So see, this equal to 0 is not there. Okay, this is just correction. Actually, I wrote the 0 there side. Okay, I stand corrected, beta. Please, this 0 was not there. These matrices are invertible. Okay, please rewrite this. This was not A plus XB equal to 0. So let me again read the question for you. A and B are 2 by 2 matrices such that these matrices are invertible. Is that clear now?
Yes, sir.
That means A plus B, A plus 2B, A plus 3B, A plus 4. This by mistake I wrote this equal to 0. Now you try. Now you try. So if a matrix 2 by 2 has integer entries and invertible and whose inverse has also integer entries, what can be said about its determinant?
Is equal to I1.
1 or minus 1, I think. Minus 1 will also do, no? Yes or no? Tell me.
Yes, sir.
So suppose I take A as, let us say, PQRS. These are the integral entries. Okay. So obviously its determinant A, which is equal to D. This is PS minus QR. Now, for A inverse to also have integer entries, see this has integer entries. So what are the entries of A inverse? You very well know, the adjoint. So here you keep like this and minus Q and minus R and divide this by D, 1 by D. This is your A inverse. So this should also have integer entries. So what does it mean? This should also have integer entries. Tell me. That means D must divide PQRS all. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
So that means what? So P into S. So D divides P. D also divides S. So can you see here? D equal to PS minus QR. So from here, I can say this D equal to D square into some constant. Because this is PS minus QR. So basically what I have done, I have taken, let us say, P equal to lambda 1 into D, like that. S equal to lambda 2 into D. So this will come out as common. So this will be lambda 1, lambda 2, and what? Minus lambda 3, lambda 4. Correct. What next? From here. So this is your D. So either D will, tell me.
D squared to the other side, right side have integers and left side should also be integers. So it should be 1 and 1.
Yes. Correct. So if I cancel this, because ultimately this should be an integer. So therefore, what is the only allowed value of D here? What is the only allowed value of D? Because ultimately, see there, what is your D? D should be an integer. So this should be only 1. Is that clear? Because if I cancel D or minus 1, so it must be a divisor of that. It must be a divisor of that. Is that clear?
Yes,
Tell
sir.
me first. Correct. So therefore, D could be either 1 or -1 for all of these matrices. Now, what will you do next? What will you do next?
The
So,
equation,
yes, tell me.
the equation A plus XB is a cubic equation with 4 roots, so it is an identity. It is true for all values of X.
Yes. No. Which equation is cubic equation?
A plus XB.
Hmm. Once you take the determinant, then only it will become a cubic or a fourth degree. See, what am I doing right now? You should claim that the determinant of this could be 1 or -1. That is how you do. Is that clear? So not cubic. First, you tell me, how did you say it is a cubic equation? Tell me.
We normally write A plus lambda I mod, we write
Yes.
it as a cubic equation. So
No, that is not cubic. That is only cubic when A and B are 3 by 3 matrices. How will that be cubic?
yes.
Suppose, see, these are 2 by 2 matrices. And mind it, if you take the determinant of this will become a quadratic right now. Okay, so this is a quadratic. Now this is 1 and -1. Now what am I going to do? I will take the determinant and square. So what will be the square of this? It will always be 1 because determinant value, this is D basically, determinant of all this. This could be either 1 or -1. Now you should say this is a biquadratic. Like that you should say. Because A plus XB determinant will be quadratic, its square will be biquadratic, and this is satisfied by, tell me, this is satisfied by 5 distinct values. Yes or no? Because we already know A, determinant A is either 1 or -1. So this is satisfied for 1, 2, 3, 4. Agreed? Tell me first.
Yes, sir.
Hence, this must be true. This is an identity because it is a biquadratic. So this must be true for all values of X. And hence, it will also be true for X equal to 5. First part, that A plus 5B is invertible. Second part, its inverse also has integer entries. Yes, because its determinant is 1 or -1. So that is obvious. Because it is adjoint upon determinant. Got the idea? All of you?
Yes, sir.
Sir, 4 cos pi by 9, 4 cos 5 pi by 9, 4 cos 7 pi by 9.
Yes. Tell me, how did you do it?
I took k as x k cos theta.
You took
X as k cos theta.
cos theta or cos theta from that. And you compare with cos 3 theta?
Yes, sir.
I will tell you why is it always possible. First of all, can you identify that all the roots are real for this? Can you identify all the roots are real? Yes. Because you can check the maxima minima, it is at ±2, and the graph will be something like this. Right? So all the
Yes.
roots are going to be real. This is easy to observe that first will lie between -4 to -3. Then next will be how much? At 2. Correct? Because value at 2 is positive, not 2, sorry. Next root will be where? -3 to -2. -2 it will become positive, right? Positive or negative? -2.
Positive.
Answer positive. Then I think 1 is negative.
0 to 1 के बीच में एक होगा सर.
0 to 1. No? So this will be 1. Yes, this will be 1. 1 it is negative. Correct. 0 will also lie here. And the third will be, let us say, for 3. 3 it will become positive. Like that. Between 2 to 3.
3
Correct.
also.
So anyway, roots are all here. See, what is the technique in these type of problems? Generally, this is known as a depressed cubic. So you know what is a depressed cubic? Which is devoid of x square term. Which is devoid of x square term. At 3 it is negative. Okay, at 4 it will be positive. No issues. So 3 also it is negative. So at 4 it will be positive. Okay. So now, since it is a depressed cubic, generally, how do you solve a quadratic? Here also you take, I will tell you a technique which will be helpful for you to solve any cubic. So if you have any cubic, first of all, can you convert it into such a depressed cubic? Divide
Yes,
off x square term that you know, right? By the transformation of
replacing x with x minus b by 3.
yes, like ax cube plus bx square plus cx plus d equal to 0. So if I replace x by x minus b by 3, then this will get converted into a depressed cubic. X square term will vanish. Okay. So this will get converted into of this form, ax cube plus some coefficient of x plus another constant equal to z by simple transformation. And how to solve the depressed cubic, that we are seeing here as a general form. So x is m plus n. What is going to be the cube of x? What is going to be x cube? Tell me. Plus 3mn into x. Right? Is that clear? Yeah. So this is x cube minus 3mnx, and then minus of m cube plus n cube equal to z. Is it clear or not? So if I compare this with this, so what is going to happen? Mn equal to 4 and m cube plus n cube, this is equal to how much? Minus 8. Correct? Now, can you solve m and n from these two? M and n? Yes, you can solve. Tell me how. So let me take like m cube equal to u and n cube equal to v. So what is the first equation? If I cube it, then uv is 64 from first equation, and u plus v is how much? So this is a simple form, u plus v equal to minus 8. So can we obtain u and v? Yes. So u plus 64 by u is minus 8. So tell me what is the value of u. So like that you will be able to solve any cubic. So from here, what is the value of u? Tell me. So minus 8 plus minus, it will be a complex number. 64 minus this. So 8 root 3 iota. Yes or no? 192 minus of 192. And this is nothing but minus 4. Or rather, I should take minus 8 outside. Can I take minus 8 outside? So minus 8 outside, and this, you know, what is this?
Omega and omega square.
Yes. So this is going to be your u. So I shall write u as not minus 8, only 8 I have taken outside. So 8 into, let me express in this form, e power iota 2 pi by 3. 2 pi by 3, that 2 plus minus I can keep. Okay. So this is your u. By symmetry, v will also be this. One is u, another is v. Like that. Getting the point? U square plus 8u plus 64. So now we are taking two cases. So suppose u is 8 into e power. So what was u basically? It was m cube. So m cube is either 8 into this or minus of this. So we can consider both cases because product of m and n is fixed, 4. So from here, once m is fixed, n is also getting fixed. Correct? So from here, you know how to deal with this. You add 2k pi, be my theorem. So what is going to be m? 2 into e power. What is that? 2k pi by 3 plus 2 pi by 9 for k equal to 0, 1 and 2. 0, 1 and 2. So what is the first value of m that we are getting? 2 into e power 2 pi by 9. Correct? Corresponding to this, what will be n? See here, product of m and n is 4. So if this is 4, the corresponding value of n will be what? Its conjugate. Is it clear? Anyway, if coefficients are real, this is a known fact that complex roots will occur in conjugation. So this will be minus I 2 pi by 9. Agreed or not? M and n. This is the m plus n for this to be true. What about next? If m is, if you put k equal to 1, that will be how much? 2 e power iota 120 plus 40, 160 degree. Let me write 160 degree. So don't panic. This is 160 degree. So n equal to, tell me, 2 into e power minus iota 160 degree. Like that I want to write. Okay. And third value will be what? If you put 2, so 280 I believe. 280. And can I write 80 for 280? Yeah, first let me write 280 only. Next I will write. So n equal to 2 e power minus I 280. Not minus. Yeah, minus only. For n it is minus. So now what are the allowed values of x? Tell me. So what are the values of x that we have obtained? So m plus n corresponding values. So 2 e power I 2 pi by n. So this will be 4 cos, 2 times real part, 40 degree. Next value will be, tell me, 4 cos 160 degree, and third value will be 4 cos 280, and 280 is also same as 80. So this you can observe 40, 80 and 160. So they obey a very interesting connection that 40, 80 and 160. If you take the thrice of these angles, that is a known angle minus half. So cos 120, cos 240 and cos 480 all are minus half. I think Ved Prakash, you connected it through cos 3 theta and then you compared it, right?
Yes.
So if you do it in this manner, then we would be able to solve any QB. Okay. So sometimes they might connect this with complex number. Yes. Anyone? Tell me, how will you proceed? After this, we will also do some previous year problems because now your exam is quite close and you should pay more attention to the trend or the type of problems that are being asked in the past 10 years. So each and every problem you should be very comfortable and you should know how to solve those problems very fast. Okay, just share me the method that you are doing so that then we can discuss.
Factorizing first part into 3 parts.
First part into?
Like constant terms, 4x power 4 plus 2x minus 2.
Okay.
But I got as 2x square into x plus 1 into 2x plus 1.
Because a parameter is involved in 2 terms here. 3x also a is there and constant also a is there. So generally in these type of problems, what we do, either we draw the graphs of 2 functions and try to observe their point of intersection. But in this particular problem, it will become a tedious task because you will not be able to actually get it unless until you involve then rigorous calculus. It is time consuming. Anything else that you can think of?
So can we
Can
we differentiate that equation, and if we get a cubic?
But that will also not solve the purpose because ultimately that cubic will also contain a term.
But
and to have all the roots, see, its graph should be like this. No? Basically, what do we require? Its graph should be like this. So if you simply take this, then you have to apply 3 conditions over here. See, 2 minimas, that should be negative and the maxima should be positive. Ultimately, that is what we intend to do. No? If we simply take this fx and anything else, every one of you is thinking in the lines of calculus only.
Quadratic in A, sir.
Yes, that is the way. That is the way. So everyone is thinking x in terms of a, but sometimes you also might observe this, a in terms of x, and this will become quite easy. See, 2x square plus x minus 1. You might have done somewhere these type of problem where we take quadratic in a. You forgot? What are the factors of 2x square plus x minus 1? Plus 1, x minus 1. 2x square plus 1. Or 2x minus 1 and then x plus 1. I think these are the factors. 2x square plus x minus. All right. Is it all right or not? So how do you factorize this now? How do you factorize this? So let me take x inside and let me multiply 2x with this. So 2x square plus 2x. Why am I doing so? To factorize this. Now factorize the middle term, splitting the middle term, quadratic. So what is the sum of these two factors, or rather difference of these two factors? This is 3x only. Tell me fast.
Yes, sir.
So what will be the factors? A minus 2x square minus x, and then a minus 2x square plus 2x. This is equal to 0. This is equal to 0. A square. I want minus 3x over there. So where shall I keep the plus sign? I think here. Now see, is it correct? Minus 3x and then minus a square minus 3x. Okay, this minus is there. Here also it is minus. Check it. Check it whether it is correct or not.
Yes, sir, correct.
Correct. Now,
Sir, minus on other side, this side plus.
I have taken it.
Correct. Yes,
Correct. So now these two quadratics, simply you put d greater than 0, nothing else. So 2x square plus 2x minus a. So otherwise, because if you take this via calculus now, it will be very tedious. So t greater than 0. So 1 minus 8a. So a less than 1 by 8. And here what? Greater than 0. So a greater than minus half. So what is the range of values? From minus half to minus 1 by 8. I think greater than equal to will also do, no issues here. So in fact, equality I should keep. So minus 1 by 2 to 1 by 8 closed interval. Is that understood now? Sometimes when you see parameter as a quadratic factor, so you might try to factorize that in terms of that parameter. So actually, this is not only that we are taking this a in terms of x. Basically, the main crux is we want to factorize this rather than keeping this intact. So factorization was the key, because this is factorizable, and that is easier to think if you take this as a quadratic in it. That is the only reason. If someone is able to factorize in any other manner in this, then not so it is okay. So tell me, is it clear?
Fourth line, can you explain how did we get 0?
Fourth line, which one, beta? This black.
Factorization, how did we do?
This one. See, 2x square into this is okay. Till here it is okay.
Yes, sir.
I have multiplied x with this term and 2x with the last term. So we arrive at this. Correct?
Yes, sir.
Now, how do you split the middle term? How do you basically factorize? Splitting the middle term. See, this is the coefficient of a is 3x. And these are the two factors. So either you take their sum or difference to be 3x. So you have observed their difference is 3x.
Yes.
Is it clear or not? Suppose you have a square minus 10x plus 8 into 2. So what is 8 plus 2? This is 10. Then you write it a minus 8 into a minus 2 like that. Same thing. Okay.
Yes, sir.
Okay. So now I am taking some previous year questions. Basically, this came in the year 97. Simple conceptual problem. Try this.
Proved, sir.
Yes. Proved, na? Yes. So this whole integral, definite integral, is a function of what? This is a function of what?
A.
Function of a, I can take. Correct. So let me take this as some f of a as 0 to a and then plus 0 to 4 minus a. So a very simple problem. 5 marks they asked at that time. Because at that time, generally what we know today, directly applying Leibniz rule. So that generally students did not know at that time, because that used to be taught in higher mathematics only. So there you have to, there they have to did it by using basic. First of all, they have to take this as antiderivative as capital G, basically deriving the Leibniz form. Now you very well know how to differentiate an antiderivative. So what is f dash a? So this is nothing but g of a minus g of 4 minus a. Okay. So now you have to show that as b minus a increases, this increases. So what is b minus a? It is 4 minus 2a, b minus a. And for a and 4 minus a is less than 2. That means 2a is less than 4. That means a is less than 4 minus a. Since g is increasing, so ga, tell me, is less than g of 4 minus a. Hence, f dash a is negative. So f dash a is negative, that means what? Tell me.
As A increases.
As it decreases, fa increases. Yes.
Yes, sir.
And as a decreases, can I say 4 minus 2a increases? Yes, obviously.
Yes, sir.
So as instead of saying this, I should say, or I can say 4 minus 2a, as 4 minus 2a increases, f increases. And what is minus 2a? This is nothing but b minus a. So this is what we wish to prove. Fa increases. So I think it is understood for all. Clear? Clear
Yes.
to all?
Can we not take integral g of x as a function f of x
So,
and f of a minus f of 0 plus f of
pardon
b
me?
minus? So we can take integral g of x as another function f of x. So we can write f of a minus f of 0 plus f of b minus f of 0 is like some function. And
Okay.
since g of x is always increasing and it's differentiable, so f of x will also always increase.
No,
So
I'm not
we-
getting your point. Just wait. What you said that you have taken indefinite integral of g as capital F. Like that you are telling, right?
Yes, sir.
You want me to write this as fa minus f0, taking integral of g equal to capital F. This is what you want to do. Okay. So plus fb minus f0. Okay. What next?
So we can write b as 4 minus a.
4 minus a. Okay.
And f of 0 is some constant that does not.
Okay. That will
And
not
since
matter.
g of x is an increasing function for all x and it's differentiable,
Yes.
so capital F also will be increasing.
Capital F will also be increasing. Why?
So because g is increasing and it's a continuous function.
Basically, g is f dash here.
Yes.
No, g is increasing means f double dash is positive. So how will you say that f also increases? G is increasing means its derivative is positive. That means f dash increases, not f increases, because g is f dash. No?
Okay, sir.
Basically, you can do it like this, but ultimately you have to differentiate. No? So what we have done, instead of assigning integral of g as something, since we already know the Leibniz rule, so we have applied that. Ultimately, if you also pick this, you have to first differentiate this better. This is small f of a. You will arrive at the same thing. Now, what you should do? You should differentiate this. So you will arrive at the same thing. F dash a minus f dash b. And what was capital F dash a? This was g that you have already defined. So this is the same thing, minus g of d. You can directly write this. Is that clear?
Yes.
Okay. So next problem. Again, previous year problem I'm taking. This you might have done. Let us see how do you approach.
The BC.
And what is the domain that he has given? Obviously, for law, it is meaning double dash. You have dash. So what dash? What is f dash? Tell me. 1 by 1 plus sin. Huh? First option, let us check whether f double dash exists for all x. So what is your f double dash? Tell me. Plus cos x divided by 2 under root 1 plus sin x. Is that clear? Which obviously does not exist for x belong to, tell me, 4n minus 1 pi by 2. So x belonging to this does not exist.
There is a
Minus
CD.
someone is getting BC, another is getting CD. Let us check what is the answer. So BC, CD. Tell me how many options are possible if you guess. 15 options. Because total 1 or more, every option could be there or could not be there. So 2 power 4, 16 and minus 1 case. When none of the option is correct, that is not allowed. So total 15 possibilities are there. If we want to take a random guess, that is why don't make a random guess. Okay, don't see, doesn't matter here. So x belonging to this, obviously A is incorrect. This is clear, na? A is incorrect because this does not exist everywhere. This is clear or not? First, tell me first.
Yes, sir.
Yes, sir.
Acha, can I tell f dash exists for all x? Check here in this domain. Yes, it exists. Can I say it is also continuous?
Sir, I have a doubt.
Yeah, sure. Tell me.
Sir, when f dash of x is equal to 1 by x plus 1 by sin x, in that, if you put sin x as 2 sin x by 2 cos x by 2, and then you can differentiate once, you will get that f double dash exists for all x.
Like you want to write this as how? Tell me. 1 plus sin x, you want to write this as?
Yes, that as 2 sin x by 2 cos x by 2, and then
Why
that
2
will
sin
be,
x by 2 cos x by 2? This is not
because you
2
can
sin
write
x by 2
one
cos x
as
by 2.
sin square x by 2 cos square x by 2,
Yeah.
and then that will be a perfect square, right?
That is okay. So what is the square root that you are writing? That's what I'm asking.
So in the square root, I'm simply writing 1 as sin square x by 2 cos square x by 2, and sin x as 2 sin x by 2 cos x by 2.
Correct?
And then I can take that
Correct.
as a perfect square and then differentiate that, right?
Just wait. What is the square root? After square root, what are you writing? That is what I'm asking. After taking square root, f dash equal to 1 by x plus. What should I write now?
Sin x by 2 cos x by 2 plus cos x by 2.
Sin x by 2 into. That is
Plus,
what
plus.
you did not say plus. No? This you cannot write. You should write mod of this. There is the mistake that you are doing. You should write mod of this.
Okay.
Understood?
Yes, yes.
It is always positive. So there lies the mistake. Okay. Even
Okay.
if you put mod here, you can see the corner points directly from here also. Okay.
Okay, okay.
So now see here. B. So B part first is okay. F dash is continuous. Yes. See, look at f dash. This is made up of 2 continuous functions. 1 plus sin x is well defined. And square root of any well-defined function is always, whenever it is defined, is always continuous. So continuous plus continuous, continuous. And but not differentiable. That means f dash is not differentiable. This is also correct. Because f double dash is not defined for these values of x. So obviously B has to be correct. Right?
On general,
Now
can we
for
say it is not
C and D.
differentiable?
No, not different. See, Suppose I say that I am an honest man. Okay. So, and someone might argue, sir, like you did this cheating some 4 or 5 years back. Okay. You took some money from your friend, you did not return it back. So can I claim that I'm honest? Can I claim I'm honest? So you cannot say that it is differentiable at many points. So why are you saying it is not? See, even if it is non-differentiable at one point in the domain, I can say it is not differentiable. Okay. So this is how actually I have written exactly the same options that JEE has asked. Okay. So in the same interval we are asking, but not differentiable. So this does not mean that not differentiable everywhere. This does not mean. So suppose I were to claim that what about 10x? So is 10x, will I say it is continuous or discontinuous? And I don't say anything. I don't say anything. So whenever this is defined, so I will say it is discontinuous. If you draw the total graph. Okay. Because see, every option has to be read in the light of the information which is given above. So it is a real valued function on this. So everything has to be dealt in 0 to infinity. It is not differential. That is why B has to be. Okay. Now, option C or option D. Option C, you have understood what is the meaning of option C? That there exists some alpha more than unity such that magnitude of derivative of function will always remain smaller than the magnitude of f after that alpha for all x belonging to alpha to infinity. So after a certain stage, alpha will come, a point will come such that if function crosses that point, then after that point, it will always be, magnitude will always be more than f. So is it true or not? I want to ask you. Is it true?
Because f
Yes,
dash
Petra.
is,
Yes, tell me.
f is continuously increasing and f dash is decreasing in some way.
You have to be very specific. When you say it is correct, you have to provide me the exact reason. You have to also tell me after this point, take this alpha, and after this is true. So can you tell me that alpha? This will always be true, even if you are not. Okay, I will tell you. See, what about f dash? Can you see f dash? Is f dash a bounded function?
Yes, sir.
From 0 plus it is starting. Okay. But the main thing is, as x increases, what is going to happen? 1 upon x will slowly decrease in 0 to 1. Is that clear?
Yes.
So can you tell me what will be the value of f dash after 1? I am telling. So I want to take this interval. When x is greater than 1, can I claim that f dash will always remain smaller than 1 plus root 2? Because first part is always less than 1, because the input is more than 1, and this part anyway will remain less than root 2. So I have taken even that value which will not be achieved. That is why I have put less than. So f dash is saying that I will always remain less than 1 plus root 2 whenever you take x more than 1. This is the claim of f dash. And look at f. Look at f. Can you tell me what is the range of f? Range of f. Is f an entirely increasing function? Yes, f is increasing function. Why? Because f dash is positive. Check here, f dash is positive always. So I'm taking x greater than 1. Is it clear or not?
Yes.
So when x approaching infinity, f also approaches to infinity. Yes. Therefore, f has to move basically if you start from 0 plus. So it has to go from, what is the range of f? Can you tell me? Its range is r. Its range is r. From 0 to infinity. Okay. So what can you claim? Since it is an entirely increasing function, a stage will come where it will definitely cross 1 plus root 2 value. It has to be more than 1 plus root 2 somewhere. Wherever it crosses 1 plus root 2, put that point as alpha, and then now read the statement C again. So there exists a point alpha greater than 1 such that magnitude of f dash alpha, that means this term, will always remain smaller after that alpha. Because once it crosses, it is an increasing function, and f dash has to always remain below 1 plus root. Is that clear? Is that clear or not?
Yes, sir.
That means for x greater than 1, f dash is a bounded function, whereas f is unbounded. So C is correct. What about D? So what is the meaning of D?
It should be
That-
bounded.
Yes, it should be bounded. So is it true or not?
No, sir.
No. Just now we have seen. So once we have seen this, there exists some positive beta such that the magnitudes of their sum or the sum of their magnitudes could be put smaller than beta for all x belonging to this. So obviously it is not possible. Whatever beta you take, f will take care that it will cross that point, because ultimately f has to go unbounded. That means it has to reach infinity. Therefore, this cannot be true. Is that clear?
Yes, sir.
Okay. Again, one comprehension I'm taking that is also useful, the concept of that.
After e power minus x into f of x, what is written, sir?
Assumes
Okay, sir.
e power minus x into f assumes its minimum.
Sir, multi-correct or single?
I think it was single correct. Paragraph. I believe it was single correct. Let me again verify. See, in this problem, they have already given you a hint, because they have asked you to do the problem for e minus x fx. So this is a very big hint. Suppose they would not have given this, even then you should have thought bringing e power x to the other side and check on your own. It is the double derivative of this. Are you able to identify this?
Yes, sir.
Good. So basically you should start with gx equal to, even if they have not asked this problem in particular, you should be comfortably taking this as your gx. So what is g dash? This will be f dash minus, right? Correct? And what will be g double dash?
E power minus x of the answer.
Same thing, na? That you can check. That will this come out as same? This is already given in the problem to be more than 1. So what does it convey? That shape of G, since G double dash is always positive, shape of G is concave up. Yes or no?
Yes, sir.
Concave. Okay. And what else? What is G of 0 and G of 1? Tell me. They both are 0. F of 0 and F of 1. No, not 0. They both are what? They both are equal. That's the only condition. No?
They are not equal. F of 0 and F of 1 are equal.
Okay, not G of 0. Okay, sorry. So let us start drawing. So what is G of 0 basically? G0 is same as F of 0. And he is asking that e power minus x fx assumes its minimum in 0 to 1. So if I plot the rough sketch of G concave up, somewhere in 0 to 1, it has attained its minima. It is already given at the point 1 by 4. So if I look at the first question, then, so before 1 by 4, what is happening? Before 1 by 4, this is a decreasing graph. That means G dash is negative. G dash is negative in 0 to 1 by 4. Agreed? So what is your G dash? That means F dash will remain smaller than F in 0 to 1 by 4. So F dash, that means C option. See yourself, all other options are incorrect. He's asking F dash is less than F for this? No. In fact, this will be positive because it is increasing. Likewise, obviously this is incorrect if C is correct. And what about D? What about D? F dash is, this is also incorrect. Check. Is that clear or not?
Yes, sir.
1 by 4 to, because after 1 by 4, both the domains he has written, not 0 to 1. Acha, now what about this? What can be said about fx? Whether fx will remain above, below, how? Let me just check whether they have given this value also. I think I remember 0 they had. Just a moment. The value of f. Yes, this is also 0. That's what I was remembering. This is given with that. This is also 0 they have. F0 equal to F1, see above, equal to 0. This is also given as an information. Okay, so now you tell me B part. Since this has no role in A part, does not make any difference. Now you tell me B part.
Option D, sir.
Option D, yes. Because now B part becomes quite obvious. The shape is concave down. So if I plot G, so I have plotted G, and G I have plotted from 0 to 1. So at 0 also G of 0 is 0. And at 1 also it is 0. And between 0 to 1, G lies below the x-axis. That means Gx is always negative. So what is your Gx? E power minus x into fx. That means for sure fx will lie below x-axis. That means option A is incorrect. Option B from strictly, why option B is incorrect? Why option B is incorrect?
We cannot surely say. And
Yes.
it is given also correctly.
You cannot surely say this value minus half. Obviously fx less than half is true. Correct? That is why it is incorrect. What about C? C is in the same manner, and only D. See, even if D, he has written fx less than 1, then also this will be taken as true. Is it clear? So there is a difference between range and inequality put in this manner. When we say range, then you have to obtain exhaustive set of values of fx. But if you put this, then any subset of that will also do. Sorry, any superset of that will also do. Suppose the range of fx is -3 to 0, for example. Then obviously this also lies in this, satisfies this. I think you are able to understand what I'm saying, right?
Yes, sir.
Okay, good.
Can you explain the
So
first
I think now, which one better?
the first question?
First part, yes. Tell me where you have down. See 0 to 1 by 4. See the graph here. So what is the nature of G? It is decreasing.
Yes, sir.
That means G dash is negative. So what is your G dash? Look here. This is your G dash. Look the pointer. So if this is negative, that means F dash is less than F.
Yes, sir.
That is what C option is there. No? F dash is less than F in 0 to 1.
Yes.
And check all other options, they were incorrect. Okay. Okay, so now you please keep doing the previous year problems also. And if we have any doubt, that also we can take in the next lecture. So I'll be taking up some more problems, more precisely the previous year ones, in which good concepts are involved. Okay. Okay, so on that note, I take your leave. Take care.